Hello guys, I welcome you all on this wonderful platform that is BYJU'S Exam Prep. And in this episode of Concept Capsule, we are going to learn about Klein Construction. So my dear, this is a part of Theory of Machine subject related to acceleration analysis of planar mechanism. Actually, whenever we are going for relative velocity approach and whenever we are going to make velocity and acceleration diagram, it is going to be very hectic task. Okay, so because whenever we are plotting the acceleration diagram, every link is consisting of radial and tangential acceleration. So Klein construction is something which is going to help us while making velocity and acceleration diagram for a single slider crank mechanism. So guys, let us see the concept of the day. It is very important topic. You can expect the same in GATE and ESC both. And guys, those who are watching me for the first time on this platform, this is 10 plus years of experience I am having. I have written many research and review papers, and guys, these are my areas of expertise, and this session is related to the theory of machines, guys. Okay, so guys, now let us move further. So my dear, when we are talking about first of all Klein construction, we should be clear about one thing, that it is somewhere related to the single slider crank mechanism. When we are talking about the single slider crank mechanism is something which is a configuration of 4-bar mechanism. When one turning pair is converted into sliding pair, then we will get this type of configuration. Here we can say this is link number 1 fixed, link number 2, link number 3, and link number 4. So there are 4 link, and 1 and 4 have sliding pair, and there are 3 turning pairs present. So we are talking about this mechanism, and guys, Klein construction talk about velocity and acceleration analysis of this mechanism. So first of all, my dear, before we start, I would like to tell you how we can make the velocity diagram generally. Then I will be showing you what was the difference Kleins have created by giving the velocity and acceleration diagram. So guys, first of all, if you have any link, okay, you know that whenever we are studying the simple mechanism, we have seen that in velocity analysis, Sir Arnold Kennedy have converted all the motions into rotation. So if we assume generally that this is any link which is in rotation, then you know very well that if this is rotating in this way, this is the omega of this link, then velocity of point B with respect to point A is given as VBA, and that is nothing but perpendicular to the link AB. So if you see, I will say that velocity of B with respect to A is perpendicular to AB in sense of omega. In sense of omega means if omega is rotating in this way, so direction will be coming in this way. If omega will be rotating that way, velocity will be going in that direction. So this is the meaning of in the sense of omega. So my dear, now we are going to use this concept to plot the velocity diagram. So if you see that, my dear, first of all, look at link number AB. If you are talking about link number AB, my dear, you can see one thing, that whenever you will be sitting at point A and looking at point B, so you know that, my dear, as omega is given in this direction, so obviously velocity of B with respect to A will be perpendicular to the link in the sense of omega. And if you want to write down velocity of B with respect to A, you will be writing, this is link 2, so omega will be 2 into AB. So AB's link length omega 2 will be given, because input link, whenever we are talking about data is given about the input link, I always says it is your birthright to get the input, then only you can find out the output. So my dear, this will be known to us. Let us say it is coming out to be 5 meter per second. So you will be taking a scale factor, let us say 1 meter per second is equals to 1 centimeter. Okay, so magnitude is known to us, direction is known to us. So we will be making a line. First of all, we will make the the points which are fixed. So A and D are the fixed point. So we have made here small a and d. Velocity diagrams are shown by the small letter. So this will be the velocity AB. You can see I was knowing the direction already. Magnitude was also known to us. So I will be plotting this line. Let us say this is 5 meter per second. So I have plotted like this. So guys, now whatever the next point we are going to get. we are going to get the next point as B. So now you will be sitting at B and looking at C. When you will be sitting at B and looking at C, you know velocity of C is going to be perpendicular to BC in the sense of omega. But we don't know omega 3. Omega 3 is not given. So if omega 3 is not given, my dear, then I would like to say one thing, that we don't know the exact direction, but that is for sure either direction will be in this or direction will be in this way. So there are two options. We are going for both the options. So we will be going for both the options. I will be plotting downward as well as upward. I don't know which is going to be the right way. So my dear, now if you are sitting at D, D means you are sitting at ground. So when you are sitting at ground, because we didn't get any new point here, so we have already used point A, now we are using point D. So when you are looking from ground, you will see that slider is moving like this. So motion of slider is very much clear, it is horizontal motion. So taking that into picture, from D I will be plotting one line, both the sides like this. So previously you were saying that this line will consist of C. Now you are saying this line will consist of C. So C will be the intersection of both the lines. This is C. So this is how we have plotted this diagram. And like this velocity A to B is giving us velocity of B with respect to A. Okay, I will write it as VBA. And guys, we can also write this. If you are showing the arrow like this, if you are showing the arrow like this, then this is velocity of C with respect to D. And if I am making the arrow like this, then it is going to be velocity of B with respect to C. And if you will show in this way, then it will become velocity of C with respect to B. So in total, we have made this velocity diagram with the normal rules to plot, with the normal concept. But my dear, first of all, I would like to say, yes, Klein's is talking about velocity and acceleration diagram of single slider crank mechanism. But when Klein's is talking about that, he is taking a condition that omega 2 will be non-zero and alpha 2 will be 0. Means whatever we are going to discuss in Klein's construction, it will be valid only if crank is not having any angular acceleration. Means crank is rotating with a constant angular velocity. This is the first thing. Now my dear, what actually Klein's says, I am telling you that. Klein's says no need to do this much work, only do a small thing. What is that small thing I am telling you? Klein's says that first of all, plot a perpendicular at A, which is perpendicular to the line of stroke. This is the first step. What I said, plot a perpendicular to the line of stroke at A. Second step is extend the connecting rod length. Extend the connecting rod length. We have connected the connecting rod length. We have expanded the connecting rod length. So after this, this is meeting at this point. Let us say this point is P. So my dear, now Klein's says that, my dear, Klein's says that if you can feel this triangle, Klein's says this triangle is nothing but the same velocity triangle. The same velocity triangle, but it is oriented by 90 degree with a scale factor of omega. Actually, I must say descaling factor of omega. Why I am saying this thing, I am telling you. In the previous case, what kind of diagram you got from the normal rules? You got this diagram. If I just rotate this diagram by 90 degree, you know my dear, this will be coming straight like this. Okay. And when this is coming 90 degree, this will also become like this. And this will become like this. So the same diagram will look like this if I will be rotating it by 90 degree. You can see my dear, when you have plotted velocity of B with respect to A, it was perpendicular to AB. It was perpendicular to AB. So this was perpendicular to AB. Now when you have rotated it by 90 degree, it will be coming in the direction of AB. It will be coming in the direction of AB. So my dear, that is why if you are going to rotate it by 90 degree, this line is coming in the direction of AB, and you can see my dear, the same was this case. This was in direction of AB. You can see in that case also, this was a perpendicular to the line of stroke, and if you see here, it is also perpendicular to the line of stroke. And my dear, this line is also that much, which is going to be there here also. So my dear, it is oriented by 90 degree. That point must be clear to everyone, but the doubt would be of scale factor. So my dear, here you have found out the velocity of B with respect to A as omega 2 into AB. But my dear, if you see in the Klein construction, in this diagram, this length is AB only. So in our diagram, it was AB into omega 2. But in Klein's diagram, it is AB only. So if you see, my dear, when you are going to say, this is going to be a scale factor of omega 2. So the point is, if you want to get the real values of velocity, these all are real values of velocity. Like if you say, what is velocity of B with respect to A? So I will be writing this length AB. If you want to write velocity of C with respect to B, I will be writing this length BC. If you want to write velocity of C with respect to D, I would be writing this length CD. But my dear, if you see in Klein construction, there you need to multiply these lengths with the omega. Like if you want to find out velocity of B with respect to A, then you need to multiply this AB into omega 2. Similarly, if you want to write down the velocity of slider, so velocity of slider is not directly AP, it is going to be AP into omega 2. Similarly, if you want to write velocity of C with respect to B, then it is not going to be BP, it is going to be BP into omega 2. So every time you need to multiply it with the angular velocity of crank. So this is something which is said by the Kleins, that you can get the same diagram with an orientation of 90 degree and with a scaling factor of omega 2. Scaling factor means you need to multiply all the sides with the omega 2. This is the velocity diagram, my dear. Now, my dear, in the acceleration diagram, if we go, for that I will be giving you a brief idea of the types of acceleration first of all. So, my dear, what is that brief idea? If you see this diagram, if there is any link, my dear, which is, if there is any link, let us say I am taking this length separately. If you have any link, let us say this link is AB, and this link is rotating with some angular velocity of omega and with some angular acceleration of alpha. This is retardation because angular velocity and alpha are in opposite direction. So you know, because of this omega, velocity will be coming in this way, that we have already seen. Okay, but my dear, now we are talking about the acceleration. You know, there are two acceleration working. One is going to be the radial acceleration. This radial acceleration is acting towards the center of rotation, and it is said to be centripetal or radial acceleration. And my dear, this centripetal or radial acceleration is given as omega square r or v square upon r. And my dear, this is always acting towards the center of rotation. And the second acceleration, my dear, which is going to be tangential acceleration, it is given as r alpha. It is always perpendicular to link in the sense of alpha. In sense of alpha. So you can see alpha is like this, so acceleration is like this, and both are perpendicular to each other. So any link in general can have two acceleration. Okay, so that is radial and tangential. So guys, let us see these two types of acceleration, how they could be shown on the single slider crank mechanism. If you are talking about this, you already know, whenever we are saying about Klein construction, Klein construction is valid only if alpha crank is 0. Alpha crank is 0. Okay, alpha crank is 0. So my dear, whenever you are going to talk about this AB link, so this AB link will be having one acceleration, that is the radial acceleration, because tangential acceleration will not be there because alpha of crank is 0. This connecting rod will be having, my dear, one radial acceleration and one tangential acceleration. And you know, slider is purely sliding motion, so it will be having only one acceleration. So my dear, as a total 1, 2, 3 and 4, total 4 acceleration would be there. If you are going to try for acceleration diagram, you know we will be sitting at point A. Okay, so that will be A dash for acceleration diagram. If you are sitting at A, you know what is the radial acceleration? It will be towards the center of rotation. Towards the center of rotation, है ना? And my dear, it is going to be towards the center of rotation, and it is omega square r. You know the direction, you will be knowing the magnitude because omega is known to us and r is known to us. So this direction is known, magnitude is known. So you will be making this direction to be like this. This is going to be this. And this point you will be getting, it is going to be point B. And it is going to be the net acceleration of B with respect to A because tangential acceleration is 0. Now you are going to sit at B. So when you are going to sit at B, now B will be the center of rotation, you will be looking at C. So my dear, there will be one acceleration which is towards the center of rotation. The point where we sit becomes the point of, yes, that becomes the point, yes, as my dear you are sitting at B, this will be the point about which the rotation is going to happen. So my dear, radial acceleration is acting towards the center of rotation. So B is the center of rotation. So this is the radial acceleration. And my dear, it will be always known to us because already you have made the velocity diagram. You know velocity of AB, velocity of B with respect to A. So this magnitude will be known to us, direction will be known to us. So direction is going to be in this way. So my dear, you will be making the direction in this way. You will be making the direction in this way. Okay, and my dear, this will be giving you x because tangential acceleration is still there. Tangential acceleration direction is not known to us because alpha of BC is not known to us. But tangential acceleration will be always perpendicular to the link, that is for sure. So we will be going with both the possibilities like this. Anywhere you can get the tangential acceleration. Now my dear, you know for the slider, the motion is going to be horizontal. As looking from ground is fixed, so A dash and D dash can be taken as together. So according to that, slider acceleration is either in this way or in that way. Either in this way or in that way. So we will go for both the possibilities, either in this way or in that way. So my dear, this you will be getting as the next point, and my dear, this will be nothing but C dash. So B dash we already got, this is C dash. So my dear, this will be the acceleration of slider. Okay, and my dear, this is going to be acceleration of B with respect to A, that we have already seen. This is the radial acceleration of C with respect to B. This is tangential acceleration of C with respect to B. So these four acceleration are making this acceleration diagram. Now Klein said no need to do this type of work. Klein said I am giving you a shortcut. What was the Klein's shortcut? Klein said, my dear, you just do one thing. First of all, you have already made the velocity diagram. This was the velocity diagram. As you know, whenever we are making the acceleration diagram, we are using, one is radial acceleration, other is tangential. Radial is omega square r. You find out omega with the help of velocity diagram. So if you have already made velocity diagram, then my dear, radial acceleration are already known to us because radial acceleration requires velocity analysis, that we have already done. So my dear, because of that, you would be knowing the radial acceleration of all the links. So here also this velocity diagram which is plotted by Klein previously, it is going to help us in making the acceleration diagram. He said this extension of connecting rod, take BP as radius and plot a circle like this. Then he says take BC as diameter and plot a circle like this. Now where both the circles are cutting each other, there join these 2 points where they are cutting each other. Then he says just extend it to the line of stroke. Extend it to the line of stroke. We have extended it to the line of stroke. Then he says this AB. Then this they have given the name of Q. And this is R. And this is A. So if you see, we are having these 4 lines. This is the quadrilateral. So I will say quadrilateral A, B, Q, R is nothing but acceleration diagram. But this diagram is oriented by 180 degree and having a scale factor of omega. You can see, my dear, this AB is nothing but it is going to give you the radial acceleration of B with respect to A. And this acceleration BQ, this will give you the radial acceleration of C with respect to B. This will give you the tangential acceleration of C with respect to B. And this will give you acceleration of slider. Why? Because you know radial acceleration is always along the link. Tangential acceleration is always perpendicular to the link. But why I said it is oriented by 180 degree? My dear, when you have plotted the acceleration diagram, you said this is the direction. This is the direction of radial acceleration of B with respect to A. But if you see in our diagram, my dear, in Klein's diagram, it is going A towards B is upward. So there you have made this direction, here you have made this direction. So it is orientation of 180 degree. If you are going to see here in the previous diagram, here acceleration of slider is going to be, this is point C, this is going to be D. So you know, my dear, if you are going to write velocity of C with respect to D is going to be this. Okay, acceleration of C with respect to D is going to be like this. But if you see in our diagram, my dear, this is the direction of acceleration of the slider. Because D and A are the fixed point, you know that. So my dear, all the times the things are oriented by 180 degree, first thing. Second thing, my dear, here you are saying radial acceleration to be AB, but in reality the radial acceleration is, you know that radial acceleration of B with respect to A is, it is omega square AB. So reality is omega square, but there in the Klein construction you are showing it by AB. So if you want to write down the radial acceleration of B with respect to A, you need to multiply with omega square to the AB. Similarly, if you want to write down the acceleration of slider, you need to multiply by omega square to the AR. Okay. If you want to write down the radial acceleration of connecting rod, that is BC, it is going to be BQ into omega square. Similarly, acceleration tangential for BC is, it is going to be QR into omega square. You may be asking, sir, you are telling with the concept for AB only and for others you are writing directly. Because my dear, for one diagram we cannot have 3/4 scale factors. Scale factor will be same and it have been seen mathematically. It is found to be same scale factor for all the values. So my dear, if I show you both the diagrams together in one slide, this is that slide. You can feel here, my dear, how you have made the velocity diagram. You have plotted a perpendicular here, extended the connecting rod. This will give you the velocity diagram, and you can see velocity diagram will be helping us to make the acceleration diagram. Then what you have done? You have make a circle by taking AP as radius. Then you have make a circle by taking length of connecting rod as a circle, as a diameter. Then you have joined the intersecting point, extended it, and this quadrilateral OARS. This is showing you the acceleration quadrilateral. So guys, hope you understood this. So this was the beauty of Klein's construction. I always used to say that whatever the work Klein's have done, it is not less than a magic. Because if even you see such a thing in your dream, you will not be able to tell it correctly in the morning that what you have seen. Because he was a big mathematician, for him giving this thing was easier. Not easier, but he have given, but it is not so simple. In understanding, people are feeling so much difficulty. So guys, hope you understood. If you want a particular concept capsule in some particular topic, on some particular topic, you can mention in the comment section so that we come up with such type of concept capsule. So goodbye guys for this session.